This video is going to show you how to write an equation of a line based off of a table of values. So the form we're going to be looking at today is called slope-intercept form, and it's represented by the equation y equals mx plus b. Now there's nothing but variables in that equation, so obviously we need to be able to put some values into that. And the values we're going to be adding into it are the m value and the b value. So in this form, the m value represents the slope of the line, and the b value represents the y-intercept, or where on the y-axis the line crosses. So if I have a Cartesian plane here with my y-axis and my x-axis, for my line, wherever it crosses the y-axis, that is my y-intercept. So it's that point where it crosses over that y-axis or that vertical line. So if I can find my slope of a line and I can find the y-intercept, then I can substitute those values into this form of an equation, and then I will have a complete equation for my line. So we're going to look at how to do that quickly just by looking at a graph. And then we're going to look at how to do it if you don't have a graph and you just have a table of values. Okay, so our first example is with a graph. So I have this graph here, and I need to find the slope of this line, and I need to find the y-intercept. And once I have those numbers, oops, this is upside down, that might help. Once I have those numbers, then I can substitute them into this equation, and then I'll have my equation for a line. So the first thing we need to find is slope. So slope is represented by the letter m. Another way to think about slope is to think of it as rise over run. So this is particularly helpful if you have a graph in front of you. So from point to point, we want to see how much is the graph rising, and then so like up and down, and then how much is it running from left to right. So we'll start at this point at the bottom. And to get to the next point, we have to rise 1, 2, 3, and we have to run 1. Okay, so we have a rise of 3 and a run of 1. And we'll see that that continues from this point to the next point. We rise 1, 2, 3, and we run 1. We rise 1, 2, 3, run 1, 1, 2, 3, and we run 1. And that's how we know this is a linear relation, because the rise and run stays consistent. It's always rising 3, running 1, rising 3, running 1. And that is what maintains a very constant slope of this line. If we were to suddenly rise 5 and run 1, it's going to get much steeper, the line would. So then the slope wouldn't be consistent and it wouldn't be a linear relation. So in this case, we have our slope. Rise of 3, a run of 1, 3 over 1 just equals 3. Okay, so we have our m value. We can plug that into our equation. Y equals mx plus b. We can now substitute our m for a 3. So now all we need to do is to find the value for b, and then we'll have a complete equation with only x and y as variables. So b, remember, is our y-intercept. So looking at this graph, it's quite easy to see where the y-intercept is. It's the point where the line crosses over the y-axis. So that point is right here. So here's my line going from left to right, and it crosses my y-axis at this point at -1 on the y-axis. So then we know that my value for b is just -1. There's nothing I need to calculate there. I can just look at it and I can see that that's where it crosses. So I can substitute that also into my equation. 3x plus, and then for b we put in a -1. Now I wouldn't necessarily leave it like this because we don't often leave it as a plus a negative number. So we would just change this to 3x minus 1. Because adding a negative number is the same as subtracting. So that would be my equation for a line. So it's quite easy to do if you have a graph. You can just look at it and determine what the slope is by looking at the rise over the run. and by finding your y-intercept by seeing where it crosses that y-axis that goes up and down. And then just plug in those values and you have your equation. But what do you do if you don't have a graph and instead maybe you just have a table of values? So let's take a look at that. I'm going to make a table of values here. So we have -1, 0, 1, 2, and 3. Over here we have -4, -1, 2, 5, and 8. So here's my table of values, and I'm going to write my slope-intercept form at the top here. So again, I'm looking for M, which is my slope, and B, which is my y-intercept. So how can I find my slope if I don't have a graph to look at the rise and run? Well, another way we can think about slope is to say the change in y over the change in x, which is basically the same as rise over run. When you're rising, you're changing your y value up and down. And when you're running from left to right, you're changing your x value. So delta y over delta x, delta is just a symbol that means change. So if you hear delta y over delta x or change in y over change in x, those are the same thing. And they're just another way of talking about slope. And rise over run, of course, also works. So change in y over change in x. So let's look at our values of y and see how they're changing. From -4 to -1, we are adding 3. From -1 to 2, again, we're adding 3. 2 to 5, we're adding 3, and so on. So we can see that our y value is changing by a +3 from point to point. Now let's look and see how our x value is changing. So we start at a -1 and we go to a 0. That is a change of +1. From 0 to 1, again, +1. From 1 to 2, +1, and so on. So our x value is changing by a +1 every time. So 3 over 1, that means that my slope is 3. So my change in y over my change in x gives me an answer of 3. So that is a value that I can plug back into my equation in place of the m value. So mx plus b. Instead of the m, I can put in a 3x plus b. So now I just need to find that b value. So if you remember that the b, being the y-intercept, it's just the spot on the graph where the line crosses the x-axis, or the y-axis, sorry. So the coordinate for this point is 0, -1. Okay, and any point on the y-axis is going to have an x-coordinate of 0. So I'll show you a few more examples of lines that cross the y-axis. So this line here crosses the y-axis at -1. So it has a coordinate of 0, -1. This one crosses at 2. So it has the coordinates 0, 2. And this one here crosses at 4. And so it has the coordinates 0, 4. So you'll notice that all of these have something in common. Any spot where a line crosses the y-axis, the x-coordinate of that point is 0. Okay, so now it should be easy, looking at a table of values, to find out where is the y-intercept. We just need to look for the place on the table where x is 0. And where x is 0, that's right here. So when x is 0, y is -1. So that is our y-intercept. B equals -1. We can tell that just by looking at our table of values. Find the place where x is 0, and that will give you your y-intercept. So now we can take that value, -1, and we can put it into our equation. Y equals 3x plus a -1. But again, we're not going to leave it like that. We would say y equals 3x minus 1, because a plus minus is kind of awkward. So instead of adding a negative number, we're just going to subtract. So you see we got the exact same answer in both methods. One by looking at our graph, determining the rise and run for our slope, and then pointing out our y-intercept. But by using a table of values, we can look at the change in y over the change in x in order to find our value for slope. And then we can find our y-intercept by finding the place on the table where x equals 0. It gives us our y value. So that's all well and good. Let's try another one. This one's going to be a little bit trickier. So I've got my table of values here. I'm going to go, let's see. I'm going to go 1, 2, 3, 4, 9, 7, 5, 3. Okay, I've got my equation, mx plus b. I need to find my slope, and I need to find my y-intercept. And I don't have a graph, I just have a table of values. Here you go, sorry about that. So in order to find my slope, remember we said slope is the same as saying the change in y, or delta y, over the change in x. So here, my y value, when I move from point to point, is decreasing by 2. So my delta y is negative 2. My x value is increasing by 1. Okay, so I have a slope of negative 2, because negative 2 over 1 equals negative 2. So that's easy enough. I can put that into my equation, mx plus b. Instead of an m, I will put in a negative 2x plus b. So I still need to find my y-intercept. Remember, your y-intercept is the place on the table where x equals 0. Because if you have a line that crosses the y-intercept, the point where it crosses, the x-coordinate is always going to be 0. So we need to find out, where does x equal 0 on my table? Well, this table doesn't have x equals 0. So what can we do? Well, what we know is that there's a pattern here where x is increasing by 1 every time. So I can go back and I can extrapolate this information. I can put a 0 here. And I've gone backwards. 4, 3, 2, 1, 0. And so now I need to go backwards with this pattern. 3, 5, 7, 9 is going to be 11. So because I know that this is a linear relation, I know that the slope is going to remain constant and that this pattern is going to continue. So I can extrapolate this information, and I know that when x is 0, y is going to be 11. So I can put that into my equation for b, negative 2x plus 11. And there is my new equation for my graph. Now I can check my answer by looking at the graph. If I were to graph it, here's the graph. I've got 1, 9, 2, 7, 3, 5, 4, 3. And I can check my slope. My slope should be a negative 2. So from point to point, I'm going down 2. So that's a negative 2. And I'm going to the right 1. So that's a positive 1. So negative 2 over positive 1. So my slope works here. Down 2 over 1. Down 2 over 1. And if I'm to continue that trend, and I want to know where this line is going to cross my y-axis, I can just draw that in over 1 and up 2. And there it is at 11. And I could keep that going for as long as I want to. I could go down this way and keep it going this way as well. Okay? But now I can see very clearly that this crosses my y-axis at the point 11. So that would be my y-intercept. Okay, so that is how you can find the equation of a line just by using a table of values, by finding the slope, by using change in y over change in x, and then by finding your y-intercept, by finding the spot where x equals 0. Hope this helped, and thanks for listening.